For this lesson, we're going to dive a little deeper into some sample problems to determine whether a function is symmetric with respect to the origin. Now, we start off with a simple definition saying that if an ordered pair is part of a set, then the negative values of that ordered pair also have to be part of the same set in order for it to be symmetric with respect to the origin. Now, that's very easy to see from a visual standpoint. So you can see maybe 1, +1, and -1, -1. Those would be symmetric, if you will, across the origin. And it's pretty clear to see. But what we really want to do is determine if we have symmetry by mathematics. And so if we can prove that f negative x equals negative f of x, so if we can just simply figure this out, does this actually exist? Apologize for the technical difficulties. Once we can show this, then we know that it's symmetric across the origin. And so basically I've set up a little table of values here that I need to fill out and determine if these two functions would be equal to each other. And so I'm just going to go to a separate document so that you can see some of the calculations here. So what I've done is I have my original function, f of x equals 1 over x to the third, and I'm going to evaluate this function at x equals to -1. Now, you can simply see that if I plugged in x equals -1 there and we negated it, I would simply have f to the 1, and that would plug in, or I can plug it in negative-wise and use the negatives. And you can see ultimately I'm going to get a value of 1 for that. Now, I could also take the -1 and plug it in over here, and then I'm going to negate the entire function, and that still gives me a positive value of 1. And so you can see here quickly that when evaluating each of these functions for the same value, we end up with an equivalent output. So let's just go ahead and plug that in. So you can see that this is going to equal to 1, and so will this. And if I did this for the remaining parts, and this should be -2, the remaining parts would be 1/8, and this would also be 1/8. If I did a +1, I would get -1 for this function, and I would also get -1 for this function. And then finally, I'd get -1/8 and -1/8. And so what this tells us is that this actually does equal. And since it equals, it is symmetric with respect to the origin. And so that's a mathematical way of showing the same thing as we see visually. Now, let's take a look at one that doesn't. Now, I think we can clearly see in part B that it's not symmetric with respect to the origin. But let's see how that plays out from the f of x standpoint. Again, I'm going to just create a quick little set of table values and see if my new functions, and I'll just use a few points, that'll be plenty enough. And so when I plug 1 into this, I get a +1, but over here I get a -1. Same thing here if I plug 2 in, I get 1/4. Here I get -1/4. And then here I get 1/9, and here I get -1/9. And you can clearly see that f of -x does not equal negative f of x. So they are not symmetric with respect to the origin. Now, we can, however, see that there is some symmetry there. And this is going to lead us to our next section where we discuss line symmetry. But as of right now, we've proved mathematically and we can see visually that these are not symmetric with respect to the origin. So there is no point symmetry.